and welcome back to my channel. In this video, you will learn how to create a model to divide a whole number by a fraction. So what is a model and why do you need to learn to use it? A model helps you to visualize a mathematical problem. You should learn to use it as another method to solving problems. It can also make problems look very easy for you to solve. So it kind of simplifies things and allow your brain to see it in a different way. So for today, we're going to divide a number by a fraction. For this example, we have two wholes being divided by 1/2. So here I have two rectangles, and I am going to divide both by 1/2. So we know that in a fraction, the denominator tells us the total number of pieces, right? So that means that one of my fraction will have two total pieces. Okay, so let's make that a little thicker. Okay, so here we have one piece, two pieces, and I'm going to do that for the second fraction. And I know right now my pieces are not completely equivalent, and that's because I'm using a pen. So let's just imagine that these two were cut into two perfectly even pieces. So here I have my first whole and my second whole, and both are being divided into two parts. And now I need to shade in one part. So how many halves can I find, or how many halves can I pull out of two wholes? Well, let's go ahead and use a different color. So for this one, I will use blue. So here's 1/2 that's being pulled out. And let's do, here's another half. So far I have two pieces. Let's change the color. Okay, so I have another half, so that's 3. And let's use, here's another half. So when I look at my model, I see that I can pull 4 halves out of two wholes. 4 halves. So the answer to this is 4. Now, obviously, there is another way that we can do this because we're not always going to have small, simple numbers, right? So there is another way that we can actually calculate this. But for right now, let's do another example with just the models before we go ahead and show you a different way. So let's look at this example. I have 5 wholes and I created 5 rectangles the same sizes for you. And I need to divide each rectangle into fifths. How do I know how many pieces to divide it by? The denominator. So this tells me to divide this into 5 equal parts. So I'm going to try my very best to cut these as even as possible to 5 pieces. Okay, so I'm going to just go down the line. So that's 1, 2, 3, 4 or 5 pieces. And again, because I'm hand drawing this, the lines are not perfect. So these are 5 equal pieces, okay? So now it says, how many 2/5 can I get out of 5 pieces? Well, how many 2/5 can I get out of one whole? So let's start there and see. So here's 1 2/5, 2 out of 5 pieces, that's 1. Here's another, so that's 2, that's 3, another 2/5, another 2 out of 5 pieces. Okay, but I see that I still have unshaded pieces. Now, can I get more 2/5 from my 5 pieces? Yeah, here's another 2/5 right here. That's 2 out of 5 pieces. Here's another. That's another 2 pieces. Another, another, and another. Well, if I look at my model, I see that I still have unshaded pieces. So I'm going to try to see if I can get more 2/5. Okay, so here's 1/5. Here's another 1/5. So that's 2/5, right? Here's 2/5 right here. And here's another 2/5. And then I see I have one piece left over. So let's go ahead and count up how many 2/5 I can get out of 5 holes. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can get 12 pieces, 12 2/5 out of 5 holes. I do see that I have one piece left over, so that will be 12 and 1/5 left over. But for this example, 12 2/5 is what I can pull from 5 holes. Okay, let's try another one. So in this example, I have 4 holes and I want to see how many 2/3 I can pull from 4 holes, or 4 divided by 2/3. So for this example, we'll do both the model and we'll do the calculation as well. So for 4, I need to cut each piece into 3 parts because my fraction says 2/3. So let's go ahead and try to cut these into 3 equal parts. And I like to draw all of my rectangles um, right underneath each other so that it's easy for me to cut them all at the same time instead of cutting them one by one. And again, we're just going to remember that these are being hand drawn, so the lines are not perfectly aligned. So there are my 3 pieces, 1, 2, 3, for each hole. And now I need to shade in 2/3. So I need to shade 2/3 and try to see how many 2/3 I will get. So here's 1/3, 2/3. Here's another 2/3 and another 2/3 and another 2/3. Now what we have to remember is we are not done. We still have unshaded pieces. So can I shade in 2/3? Yes, here's 1/3, and I'll shade it like this so we can see. And 1/3, 1/3 plus 1/3, we know is 2/3. So that's another 2/3, right? So right here we have another 2/3. Here's another 1/3 and another 1/3. So again, we have another 1/3. So if we were counting this up all together, we see that we have 1 2/3 here, another 2/3 here, another right here, and here. So far 4, 5, and 6. So we can pull 2/3 out of 4 6 times. So let's look at the calculation version. If we did not have to draw a model, or if this was larger numbers, how would we do it? Well, there's actually a strategy for this. We want to keep the first number. So keep first number. Okay, we're going to keep the first number. Then we're going to use the inverse operation. So in this case, our original operation is division. So the inverse of that would be to multiply. And then we're going to flip or use the reciprocal of 2/3. So if we use the reciprocal, then we would flip 2/3 and that will become 3/2. So let's follow along with my steps. So step 1 is keep first number. So 4. Step 2 is to use the inverse operation. So we have division, so that means I'm multiplying. And step 3 is to flip the fraction, so now it changes to 3/2. So we already learned that a whole number can be a fraction, right? So I can make this whole number a fraction without changing the value by putting it over 1. 4 divided by 1 is still 4. So my value did not change. And we know that when we multiply fractions, we multiply across. So 4 times 3 over 1 times 2. When we multiply 4 times 3, we get 12 over 1 times 2 is 2. And 12 divided by 2 is 6. So my answer is the same. So once you get really good at understanding the model, you'll realize that doing it using calculation is just as easy and more efficient when you have larger numbers. Let's take a look at this next problem and we'll try to do it both ways. So here I have 6 wholes being divided by 1/4. So 1/4, how many times can I pull 1/4 out of 6? So again, my denominator tells me how many total pieces I will have when I cut each whole. So I will have 4 pieces. So I am going to cut this into 4 equal parts. And again, because it's being hand drawn, it is not perfectly even. Oh, wow. Okay. So there are my 4 equal parts. So I need to do the same thing over here because it's 6 wholes. So again, I apologize. I cannot draw a straight line. So 4 pieces. So now I need to see how many times can I pull 1/4. So here we go. 1, 2, these are 1/4, right? So this is 1 out of 4 pieces, 1 out of 4 pieces, another 1 out of 4 pieces, another 1 out of 4 pieces. So far I'm able to pull 4 1/4 out of 6. So if we continue this pattern, another 1/4, another 1/4, another 1/4, 1/4, 1/4, 1/4. We see there are 4/4 in one whole. So if I'm pulling 1/4, that means I will get to pull 1/4 4 times from each whole. So once you recognize that pattern, you could stop and just multiply, but we're going to continue to do the model. So in this first whole, we pulled 1/4 4 times. Here's one, here's another 1/4, another 1/4, and another. So we did that 4 times. We did the same thing for this whole and the same thing for this whole. Over here, we did the same thing for this whole. We were able to pull 4 1/4 each whole. So we can, oh, I'm sorry. Let's erase that and put a 4. Okay, so there are 2 ways to add this up. We can add each individual numbers and we would get 12 here and 12 there, and then we can put them together. 12 plus 12 equals 24. And of course we could just do 4. How many times do I see 4? 1, 2, 3, 4, 5, 6. And 4 times 6 equals 24. So these are just 2 ways you could do it. If I wanted to do the calculation for this, right? Remember, we're going to keep, so let's just draw a line to separate this. We're going to keep the first number, so that's 6. We're going to use the inverse operation of division, which is now multiplication. And then we're going to flip the second number, which is a fraction. So 1/4 flipped would be 4 over 1. Next, we will put the whole number over 1 to make it a fraction. And now we have 2 fractions that we're multiplying, so we would just multiply across. So this becomes 6 times 4 over 1 times 1. 6 times 4 equals 24. 1 times 1 equals 1. And we know that 24 divided by 1 equals 24. So I can pull 1/4 out of 6 24 times. Now in this last example, I want you to pause the video and try to do it on your own. Go ahead and pause the video now. Okay, so the denominator tells me I need to cut my wholes into 5 equal parts. So I'm going to go ahead and try to cut these 5 pieces. and do the same thing here. Okay, so now I need to pull 1/5 from each hole. So here's 1/5, that's 1 out of 5 pieces. Here's another 1/5, 1 out of 5 pieces, and another 1/5, 1 out of 5 pieces, and another and another. We noticed, just like our previous problem, that 1/5 I can get 5 1/5 out of one hole. So because these are all one hole, I know that I will get 5 pieces from each hole. So I'm just going to write 5 next to each hole because I shaded in 5 pieces there. I can continue this pattern, but we already recognize the pattern, so we don't need to do that, right? We need to be efficient. So now I'm going to say 5 times, how many 5s do you see? 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh, we have 8 rectangles, so we'll need to fix that. We needed 7. So 1, 2, 3, 4, 5, 6, 7. So we do not need this last rectangle. That is one too many rectangles. So let's mark this out. So that will give me 7 rectangles. Let's double check. 1, 2, 3, 4, 5, 6, 7. Very good. So I see 5 1/5 7 times. Or I can go ahead and add 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5, and I'll still get the same answer. So 5 times 7 equals 35. So using the model, I am able to figure out that I can pull 1/5 out of 7 35 times. Now let's check our answer with the calculation. So my step said keep your first number, so that's 7. Use the inverse operation of division, so that's multiplication, and flip the second number. So 1/5 flipped on its head would be 5/1. So now let's go ahead and calculate. I have a whole number. I can change that whole number into a fraction by putting it over 1 without changing the value. And now I have 7 times 5 over 1 times 1. 7 times 5 is 35 over 1. 35 divided by 1 equals 35. I hope you also got 35 in your answer. If you need to rewatch this video, you can watch it as many times as you need. And remember, when we're dividing fractions, we can draw a model to help simplify things for us, or we can do the calculation. Doesn't matter. Whichever one works best for you, that's the one you want to do. I hope this video helped you.